Hello, my name is William Roy. I'm with Math 1000. I'm doing my Math 1000 video. So what we have here is that we need to go ahead and we have the instance of, we have f, 2g, 2h. And we want to find 2a, all these to a, and we want to find the derivative of this. So now what we're going to have to use, we're going to have to use a chain rule. We know what a chain rule is, what the definition of f, when f prime, well, let's say you have f is equal to f to g at a. What we know that this is equal to is that when f to prime of x is equal to the derivative of g of a multiplied by the derivative of f of g of a. And then so we know that this is our definition of the chain rule. If we were to go ahead and use the chain rule and put it back through, we would get that. So our derivative of when we have f to o, f to g to h would equal h prime of a times g prime to the h of a multiplied by the f prime g of h of a. And so now the derivative of f of x to the f of g to the g of h to a is going to equal to h of a times the derivative of g to the h of a times the f of 1 to the g to the h of a. So now, let's say we have the problem. Let's say we have a problem like this. Let's say we have the problem f of x is equal to e to the power of the sine of the square root of x, to where x is close to pi squared, in terms that pi is equal to 3.14, or the actual value. So for this, we're going to have to use a chain rule. So with the chain rule, first we'll start by going ahead and use it. So now we know that when we're going to apply the chain rule to this, we get that. So let's say the f prime of x is equal to e to the sine of the square root of x multiplied by the derivative of the sine of the square root of x. And so that's the first step. That's the first step where we apply the chain rule. Now we go ahead and we take the derivative of our square root of x. So what we get then, well, no, we're going to have to go ahead and apply the chain rule again, since we know we have the sine to the sine to the square root of x, and we apply the chain rule again, since we have that square root of x. We still have to go ahead and find the derivative too. So then next, what we do is that we go ahead and we take, we'll have that equal to the cosine. We have that to the cosine of pi x multiplied by the derivative of the square root of x, if I'm not mistaken, the square root of x, times e to the sine of the square root of x. So now, as you can see here, we went ahead and we applied the chain rule again. So what we have to do now is that now we'll go ahead and we simplify. So when we simplify, we go ahead and we put everything together. So we know that this right here, the derivative of the square root of x, is going to equal to 1 over 2 times the square root of x multiplied by the cosine of the square root of x multiplied by the e to the sine of the square root of x. And so now what we could do is that this will equal to the cosine of the square root of x multiplied by the e to the sine to the sine of the square root of x, all of this over 2 to the square root of x. And this right here is going to be our derivative of e to the sine of the square root of x. It's just the simple parts of applying the chain rule and applying it back and forward to whenever we need to go ahead and take the derivative of something. So next, we have another problem. So now this problem is where we have x squared plus xy plus y squared is equal to 7. And what we need to do here is that we need to find the common slope of this function. So the way we would find the common slope of this function is that first we go ahead and we know that with every function there's always going to be a point where y is equal to 0. So because we know there's always going to be a y-intercept. So what we can do then is that we set y equal to 0. So then we get x squared plus x times 0 plus 0 squared is equal to 7. Since this pretty much goes and cancels out, and this gives us 0, we then get x squared is equal to 7. Take the square roots on both sides, and we get that x is equal to the square root of 7, plus or minus. Because remember, this is the square root, so we have to take the plus. It could be plus or the minus. So next, what we do is that now we realize that our points are going to be the square root of 7 when y is 0, and the negative square root of 7 when y is 0. So those are going to be our 2 points. That's going to be our 2 points for our slope that we're going to use to find our common slope. So then next what we need to do is that we need to take the derivative of our function in order to go ahead and find the slope. So our derivative for this function, so we go ahead and take the derivative of our function. The derivative is going to equal to 2x. Well, first what we have to do is do a little bit of implicit differentiation. We're going to get 2x plus y multiplied plus y plus x plus 2y to dy dx. Now the reason why dy dx is that we're doing implicit differentiation. Back here in the derivative of this, since we have y's, we don't have it to the derivative of x. So what we have to do is that we go ahead and set it so that we have that this right here is the dy dx. So we're taking the derivative of y in respect to x. So the next what we need to do is that we set the dy dx, because we need to find that out first before we go ahead and start putting things in. We need to figure out the dy dx is equal to. So when we go ahead and we do that, is that we're going to get that dy over dx is equal to the negative x squared. Minus y over the x plus 2y. And then when we get that, all we have to do now is that we have to go ahead and put in one of our points. So a point we could put in, for example, would be this point right here. When we put that point in, what we get is that dy over dx is equal to the negative x, the negative 2 of square root of 7 minus 0, because right here at this point, y is equal to 0, over the square root of 7 plus 2 times 0. And remember again, since y is 0 at this point, we put 0 right here. So then we get that the dy over dx is equal to the negative 2 square root of 7 over the square root of 7. And now, since we have 2 similar terms here, we cancel these terms out, which then gives us negative 2. So then our common slope for these 2 points right here, our common slope is going to equal to negative 2.